So we'll talk about now the transport layer. And this is the fourth layer of the OSI model. This is the fourth layer, the OSI model. Why is it very important? Why are we even studying it in the first place? Okay. And so we're going to realize that transport layer is such an important uh, uh, chapter to study because its major purpose is managing communications from one application to another application, WhatsApp to WhatsApp, browser to browser, Gmail application to another Gmail application. Okay. Right now we're using the Microsoft Teams. So from my teams to your teams, everything right now is actually being managed by the transport layer. And so here we're going to talk about two major protocols, the TCP and UDP, and all protocols. They actually, all services, they must actually belong to either TCP or UDP. And we did talk about MAC addresses. We talked about IP addresses. Now today we talk about another number, which is called port numbers. We call it port numbers, and very, very interesting as a protocol. Now, so it's important that we, get to understand what is the work of the transport layer. And so to start us off, let's talk about let's check on the transportation of data. So clearly, we can see that this is the protocol that's responsible for logical communications between different running applications found on our host devices. Okay, all the applications. For your Facebook to communicate with the Facebook of another user, the transport layer is very crucial. And it's also the link between the application layer and the lower layers that are responsible for network transmission. And so you can be able to see from the voice over IP phone to another voice over IP phone, from one video conference to another conference device, one PC to another PC, and your mobile phones. The applications that run on the mobile phones are all managed by using the transport layer. So now, transport layer is responsible for tracking individual conversations. And that means one thing that I had mentioned to you some time back is that as messages are being transmitted, the messages must always be divided into small units. And we call that process segmentation. And each and every small unit is actually given a number, and we call that sequencing. We give them sequence numbers. Now, I have another story for you guys. Remember another parable like I did yesterday. Imagine you are selling some commodities online, and you're gonna take up their photos that you post online. So let's take an example of shoes. All right, take an example of shoes. So you're selling shoes online, and you have clients from all over the world. All right, and so what happens is that one day there's one of these clients who stays in Nigeria, for example, or he or she stays in Dubai, and they get to see your shoes online. Maybe it's on Facebook, or it's on Instagram, or it's on Twitter, whatever that is. All right. So they see your shoes, and then they inbox you. They send you a message, that, you know what, I like your shoes, and I would like us to make a transaction. So at that point, you need to you tell them you'll make a payment, of course, upon delivery. So you now package this pair of shoes and you send it. You send this pair of shoes to wherever they are. So the moment you make the dispatch, all right, you have to let them know, either in an email or you send a WhatsApp message or something like that. So you send them a message, which means you must establish initial communication with the recipient or with the client before you even send the parcel, okay? That initial communication is important because it builds a good rapport and it basically builds trust between the two of you. So, so you establish that communication. Number two, as the parcel is moving, the parcel can be tracked. Some of you have used Jumia, for example. It is always tracking. It's always tracking. It's always tracking the goods as they're being sent. Okay, and so this process of tracking goods and the sender and even the recipient can track the goods. It's something that is very related to what is happening at the transport layer. Okay, of course, we did talk about segmentation and reassembling. The goods are always divided into small portions or the messages and the given sequence numbers, which are going to be important in reassembling the segments. And remember, the PDU at the transport layer is called segment for TCP, but UDP calls it datagram, since UDP means user datagram protocols. UDP means user datagram protocol. So, so these sequence numbers, of course, are used to identify, separate, and even manage multiple conversations, and we call that multiplexing. Now, let me try to paint a clear picture here. So this is what I'm saying. You have a computer here, and on this computer, you have opened your browser, and you're browsing so many things. You know, yeah, there are so many tabs you have opened, and these tabs that you have opened, one of the tabs is on a Gmail account for email. One of them is you're running WhatsApp web on there. One of the tabs is running web pages that you're visiting. Maybe you're doing some online search. One of them is having an online video chat platform. And one of them is on YouTube. You're streaming some live video, okay? And so the different tabs are the multiple conversations that we are talking about here. So each and every session must actually be identified. And so TCP and UDP are the two major protocols that manage all those communications, and they manage the applications we find at the application layer. Talking about file transfer protocol for downloading or uploading files. Excuse me. Talk about web traffic with the HTTP or HTTPS. Talk about email traffic with SMTP or simple mail transfer protocol. Talk about DNS and even trivial file transfer protocol. Okay, TFTP. So all the protocols of services ran at the application layer, they must pass through either TCP or UDP layer 4, so that they're given some what you call port numbers. And so today, let's start with the TCP, Transmission Control Protocol. Now, the story I was telling you about, the shoes that you're sending to someone who is far away, you're able to track the shoes. Now, when the shoes, let's say you are sending 2 pairs. So when the pairs reach the owner, the other side, you actually realize you didn't send complete 2 pairs. You actually sent 1 complete pair, and the other pair you had sent only half. So the guy, the other side, of course, will only tell you, I only received 1. So they'll only completely acknowledge what they received, all right? Anything that they didn't receive, like, you're having a pair, I mean, a shoes that is not in pair, one side of the leg is missing. So, the client can be very furious with you and they might not even talk to you. Now, what am I talking about? What if they received everything as was expected? They'll send you acknowledgement. They'll say, thank you very much. I got them and I can now pay you. So if you don't send everything well, they're not going to pay you. Now, if you realize that you only sent shoes and one side remained at your house or your store, you will not need to send the whole pair again. You only send the side that that remain. Now, so it's important to note that transmission control protocol, unlike UDP, user datagram protocol, TCP is a very reliable protocol. Why the reliability? Because it's the one that can number and track the segments as they are moving from one application to the next. And for TCP, unlike UDP, they acknowledge every data that is received. They must send an acknowledgement message, okay? And any data that was not received, TCP will retransmit that particular message that was the particular segment that was not received. It will have to be retransmitted. That's very, very important. Now, TCP data is always sent in a sequence so that if it arrives in the wrong order, it must be rearranged, unlike UDP. One more thing about TCP. Let's say you're sending data from one computer to another computer, which have different applications. If the destination application or device is low in memory, low RAM, low processor, and it's low in resources, the source device can actually reduce the amount of information it will be able to send to the destination device. And that happens to control or to send data at an efficient rate that is only acceptable by the receiver. So if the receiver is low on resources, then the source will always detect and it will reduce the amount of information it's able to send. So that is TCP. UDP, which is user datagram protocol. Now, I had talked to you that TCP is also what's called connection oriented. Why? Because TCP must always establish a connection with the destination device before sending the actual data. UDP, and so we call it TCP a connection oriented protocol. We call it connection oriented protocol. UDP does not do that. UDP does not establish any initial session before sending the actual data. And so UDP is always called a connectionless protocol. Now with UDP, the reason why it's known as a best effort delivery protocol is because delivery of the messages is never guaranteed. It can reach or it might fail to reach, And UDP, of course, does not send any acknowledgement, and it does not retransmit any data that was not received. It doesn't send acknowledgement and doesn't do any retransmission of unacknowledged or undelivered data. So UDP, it's easy. It takes things very lightly, Let the message reach. If it doesn't reach, that's okay. Now, something funny enough is like TCP and UDP, each of them, they are only suitable for sending specific types of information. For example, all the live streaming information, whether you're watching a live video online or on YouTube or the meeting we're having right now. This meeting is actually being done on UDP. Okay, this meeting is happening on UDP, and if we want to configure, if we want to test that, we can actually do that here. Let me filter some UDP protocols here, and I think it uses something called RDP. Let me see RDP. RTP. RTP. It's not RTP. It's called I'm gonna see it just here. Let me see. Let me just restart this, and you're gonna see it right now. Can you stop without saving? So since we're having a live meeting right now, we should be able to see some live streamed data here. Let me just restart my Wireshark. Okay. And I can start Wireshark afresh. Yeah, because I want you guys to be in touch with the reality so that you can be able to see what exactly that we are doing. So I'm gonna capture on Wi-Fi and you can see, yeah, we can see some arrays. It's called what? Let me just show you here. Yeah. Okay. They're running so fast. And there's a TCP bucket there, as you can see. And yeah. Let me just capture because STUN is a very common. Yeah, I think it's RTCP. Let me see RTCP here. And this is RTCP protocol. Yeah, real-time transport protocol. This is exactly what I was looking for. Real-time transport protocol, RTCP. Let me filter it here. RTCP. Okay, yeah, you can see them here. You know, so this is real-time streaming protocol. This is the real-time transport control protocol. Yes, this is the protocol that is actually running because we're having. This is like it's almost video traffic and audio traffic. So there's a combination of the real-time transport protocol because we're having a real-time communication. Okay, RTP will be the real-time transport protocol. This is now the one for the real time because we're having a real time communication as we speak, and that's why it is using the RTCP. It's using the RTCP. So this is a very good example of my Wireshark capturing all these payloads that we are keep on sending and receiving there. So like I was mentioning, guys, to you, is that any live streamed content uses UDP, okay? And that includes voice over IP, DNS is among them, and they are always very fast because they don't have any overhead, okay? Like I mentioned, no acknowledgements, does not resend any lost data, and delivers data as it arrives. And that is this guy is not reliable, and it is a connectionless protocol because it doesn't do the initial establishment of a session. This guy is very reliable, sends acknowledgements, it resends any data that is lost, and delivers data in a very sequenced order. This is TCP. Things like email, okay? Things like web pages, SSH, all these are actually reliable protocols, so they use TCP for them. But any real-time streaming, like making a call, of course, DNS and UDP, I mean DNS and DHCP sometimes can also use both UDP, and they can also use what? They can also use TCP. Those are two very unique protocols. Those are two very unique protocols. Now, like I've said, we back to TCP again to get a deeper look. TCP does what is called session establishment. And this is what we call the TCP three-way handshake, which we are going to look into in a few. So it establishes the session, begins to send information. When it has sent all the information that it needs to send, then it must terminate that session. So the session is actually prepared to prepare, the way for sending information from a source to a destination. So TCP must establish a session before sending the actual data. UDP will not. Reliable delivery is for TCP, okay? Same order delivery is for TCP, and then flow control, okay? Does the destination device have enough resources? if it doesn't have enough resources, then what am I going to do? I'm going to reduce how much information I can be able to send. I can be able to send. And so looking at the header for TCP, it has so many details. It's very detailed here. We can see, place for sequencing where the sequence numbering is actually done. Sending acknowledgement, you can see there. The other control bits, urgent fields, checksum for error checking and all that. So this is TCP header. It's made up of so many fields because it's very detailed. To ensure reliability, it must do so many things. Now, what are some of the protocols that support TCP? You can see HTTP and HTTPS as well. You can see FTP, file transfer protocol. You can see simple mail transfer protocol, and you can even see SSH. All these are protocols, and they're not just them, so many of them. All these are protocols that require reliability, and that's why they choose to use TCP. Now, for UDP, like I've already mentioned, there's no session establishment. It doesn't resend any data that is lost. Data is just reconstructed in the order that it is received. And they do not send any information about resources availability at the destination. And that's why if you look at the fields for UDP, just source port and destination port, the length and checksum, and that's it. It's very simple header, and it doesn't have so much details per se. Now, if you look at the applications that require UDP, we have video conferencing, very important. Any calls that you make, voice over IP, okay? TFTP, Trivial File Transfer Protocol, SNMP, Simple Network Management Protocol, DNS, Domain Name System or Service, and then DHCP is Dynamic Host Configuration Protocol. These are protocols that use UDP, but it's important to mention that we have two of them, which is DNS and DHCP, which can always use both TCP and UDP, and it depends on what is actually happening. Not all the time, not all the time. Now, let's now talk about this that we call port numbers. Now, you need to note, and we'll be talking about them. We have three categories of port numbers. Now, wherever you open your browser and you're running so many tabs, each and every tab is actually called a session. Each tab is called a session, and each session is actually assigned a unique port number at the source. The operating system of your computer will assign a unique port number. Assign a unique port number to your PC. Each of them will assign a unique port number to your to the sessions. The operating system will assign unique port numbers to every session on each and every tab there, and it will be a source port. Remember, a packet must have a source IP address and destination IP address. A frame must have a source MAC address and destination MAC address. So a segment must also have a source port number and destination port number. Most source port numbers are always assigned by the operating system of your device, but the destination port numbers are always telling us. Yeah. So each source port number will be assigned by the operating system, but the destination port numbers are always indicating the service that the device is seeking. And remember, when you enter gmail.com, okay, you are actually visiting a mail server. You enter google.com, you're visiting a web server, and we have each of those services have unique port numbers. Now, before I take you through the port numbers, one of these days you'll be asked, what is the combination of an IP address and a port number? That one is called, we call it a socket pair. A socket pair is the particular port number, the port number and the IP address pair is actually called a socket pair. Now, I want you to note something here. We have a PC here, that is running 2 tabs. This PC is running 2 tabs. The first tab is going to, it's visiting a server. So we have one server here, which is running 2 services. It's having web pages, so it's running web services. It's also carries files that can be downloaded. We call that FTP, the protocol. Now, since this PC is browsing, the PC is browsing the web server there, which is also having FTP services. And so remember, the PC has an IP address, which is 192.168.1.5. The server has an IP of 192.168.1.7. All right. So the PC will automatically generate a unique port number. The PC will generate a unique port number. And you can see the operating system of the PC generated 1305 for FTP services for the file it is downloading. And it is going to also generate, the operating system generate another port number, 1099, which is for the web traffic. So when the packet leaves or the segment leaves the PC towards the server, the source port for each and every session or for each and every tab will have 1305 for FTP and 1099 for UDP. Now, those ones will be our source ports. And that source port together the IP address here is what we call a socket pair. And you can see them here. Source IP and source port there. Okay. So what about the destination? The destination device obviously has an IP. You can see IP will be for the packet. It has a MAC address for the device at the data link layer for the frame. And for the segment, it will also have a what? A port number. Now, some port numbers like port 21 here, port 80. These port numbers have been reserved for specific applications running on a certain device. For example, you meet any person and you tell them port 21. They know you're talking about FTP. You talk about port 80. They know you're talking about HTTP, which is for web services. Port 443 is for HTTPS. And so that brings us to, a point where we need to just talk about, we need to talk about this thing of port numbers right now. Now, we have 3 categories of port numbers. 3 categories of port number. And the first category are called well-known port numbers. Well-known port numbers. The well-known port numbers, which is from 0 up to 1023, these are port numbers that have been reserved for common or popular services and applications like web browsers, email clients, remote access devices, so on and so forth. Of course, I will take you through some of the well-known port numbers in a few on the next slide. But these port numbers are reserved and they are used to identify specific services. For example, talk about port 53, port 69, 67, port 53, port 132, so on and so forth. So I will take you through that. So these ones, they're reserved and they represent common services that are run within our devices. And it ranges from 0 to 1023. Now, the second category, we call them registered port numbers. Registered port numbers. The registered port numbers start from 1024 all the way to 49,151. So these are port numbers that are assigned by IANA, the Internet Assigned Numbers Authority. And they are assigned by IANA to any device, any entity, organization, or a person that is requesting to use that specific port number for a particular process. And so you can, of course, pay for it and you request to use that particular port number. A very good example, because Cisco has a server called a radius server. The radius server is actually a type of server which is used for authenticating users to the network. Give an example like our telecommunications companies. Like I know that on the globe, the whole world knows something called M-Pesa, all right? And so M-Pesa users found all over the world, the M-Pesa users, for them to authenticate and log into their gadgets, without experiencing any problems securely, there's a radius server which is used for authenticating a large group of people, all right? So if you want to authenticate a large group of people, the radius server is a very, very good one. And so Cisco requested to be reserved for the radius server, port number 1812 for that particular service. So anyone, you can do that, make the request, and it will be reserved for you, because I think at a service fee. The last category is what we call the private or dynamic port numbers. Private or dynamic port numbers. These port numbers are also known as ephemeral port numbers. And these are the ones I was talking to you about, which are normally assigned by the operating system of any device. Any device assigns, any session is assigned a particular port number by the operating system. So they range from 49,152 to 65,535. All right. So those are the ephemeral port numbers. We persist to assign every session a unique port number, a unique port number. So that is now let's look at some of the well-known port numbers here. And these ones, you need to have them at your fingertips. You need to have these ones at your fingertips, okay? And so we start with some very familiar ones here. We have for 20 and for 21, this one's for FTP. For 20 and 21 are for FTP. Then we have for 22 is for SSH. For 22 is for SSH. For 22 is for SSH, which is secure shell. And you realize that those ports are actually under either TCP or UDP, okay? Then we have port 23 is telnet for remote access, just like SSH. Port 25 is for email, simple mail transfer protocol. Port 53 is for DNS, domain name service. Port 67 and 68, those ones are for DHCP. One is for DHCP server, another is for DHCP client. Port 69 is for TFTP, trivial file transfer protocol. Port 80 is for HTTP, and 80 also goes with 8080. All those are for HTTP. Port 110 is for post office protocol, POP version 3. 143 is for IMAP, the Internet Message Access Protocol. And then port 443, obviously, we have 161, which is for SIPO Network Management Protocol. And 443 is for Hypertext Transfer Protocol, secure, HTTPS, okay? Like for HTTPS, okay? So it's important that we get to know the specific port numbers, know your port numbers, and make sure that you have a bunch of them. You need to have them at your fingertips so that you know which service is being referred to as there. Okay. Okay. So that is very important there for us. Now, if you want to see some of the sockets, as we had mentioned, there's this command called netstart. Netstart without an R. So you put netstart on your command prompt, CMD. You can see here some you can see here some sockets here. So this is a TCP session, and you can see the IP address here, colon port number here. That is a socket IP with the port numbers here. And sometimes the IP might not be the IP itself, can just be the domain name and with the HTTP. Instead of putting 80, they put HTTP. Instead of putting the IP address, they put the what? The domain name here. You can see cisco.com colon HTTP. So cisco.com, which has its own IP address, and the HTTP is port 80, as we can see that here. Okay, so that is very, very important for us here. Now, I want us now to look at communications, TCP communications, and we look at specifically the TCP three-way handshake. TCP three-way handshake. And so for the TCP three-way handshake, we do have this PCA and PCB, PCA and PCB. And this PCA and PCB, we have, this is what I was calling the session establishment. We call it the TCP three-way handshake. How does it happen? Remember how people greet each other in Swahili, okay? So in Swahili, people say, habari yako. We say habari yako. When you tell someone habari yako, the person replies nzuri sana. That is a Swahili word, nzuri sana. So when they respond with nzuri sana, they also greet you habari yako, okay? And then you respond with nzuri sana. So you say, how are you? And then the other person responds, I'm good. And they ask you, how are you? And then they tell you, I'm good. So the first greeting is called the syn, to synchronize, a synchronization greeting. When you're greeted, you need to acknowledge that greeting, and you also initiate or synchronize another greeting to that person, and that person acknowledges. That is why we call it the syn arc, and arc. Syn arc, and arc. That is what's called the TCP three-way handshake. Very, very important. This is how TCP applications initiate communications, and this is the session establishment. So they establish the session. Once they establish the session, then they begin forwarding information. Once they are finished forwarding the data they need to transmit between the two applications, they now need to terminate that session. They need to do what? To terminate the session. And to terminate the session is normally terminated from both ends. So the PCA will start by sending a message called fin, basically meaning finish. So fin, and PCB will send an arc, okay? PCB will also send a fin, and the other PCB will send an arc. So fin arc, fin arc, fin arc, fin arc for session termination. All right? That is very, very important. Now, in terms of, I had mentioned this for datagram reassembly. We said in TCP, the information is always, rearranged using the sequence numbers, so that if we had sent data sequences 1, 2, 4, 5, or 1, 2, 3, 4, 5, 6, sometimes looking at what is here, in UDP, data is always arriving in wrong order, and it doesn't matter. But TCP will have to rearrange this data in the correct order, and that is one big advantage we have with TCP over UDP. TCP over UDP. Yeah, and this is basically the end of this particular study on TCP and UDP. We can basically look at the last thing now. We can look at the last thing for today, which is called transport layer. So not transport, application layer. And in application layer, we are going to basically we will basically talk about the application. It's actually like a summary of the whole course as we have been